So today, we are going to use the Pythagorean Theorem Converse to classify triangles. That is, after we've determined whether or not we can have a triangle, we're now going to use the converse to determine what type of triangle. So by way of review, we looked at this first one, hashtag. We looked at this first one right here. And we said that if c squared plus a squared equals a squared plus b squared, then the triangle is a right triangle. And we can use a 6, 8, 10 triangle just to check that. If I have a 6 here, an 8 here, and a 10 here, the question is, does this make a right triangle? So since this is my longest side, then longest is going to be my C. So now I can just say 8 squared plus 6 squared equals, with a question mark, c squared, because I don't know yet. And continuing through, this is 64 plus 36 equals c squared. Then I get 100 equals c squared. And since I'm dealing with only positive, I'm dealing with side lengths. Wait, what am I doing here? I should have actually substituted in there. Should I start? All right, and so in the end here, we see that C is 10, which corresponds to exactly what we got there. So I should have substituted into there and just set an equal sign. For now, this is sufficient. So we do see that they are the same, and since they are the same, this is indeed a right triangle. That a squared plus b squared is equal to c squared. So they are, the Pythagorean theorem works, so we have a right triangle. So let's walk through this example right here. Determine if this puppy here is a right triangle. So again, let me set up by putting in the Pythagorean converse. I'm going to start with the c squared. I'm going to put an equals with a question mark because I'm not sure. A squared plus b squared. So c is my longest right here, so I'm going to put 65 squared there, equals, and it doesn't matter which one you call your legs, but both of these two are my legs. So 4225 is equal to 1089 plus 3136. 4225 comes down, and when I add these two together on the right, I get 4225. Since that is a true statement, my conclusion is I have a right triangle. Tell whether it is a right triangle, and the answer is yes, it is a right triangle. And you can abbreviate RT with a triangle symbol. All right, this one's a little bit more of a booger because we have a radical in there. Now, it turns out that dealing with radicals is not as complex as we may think. So again, I'm going to start off with c squared is equal to a squared plus b squared, and I have to determine which is my c. This is my longest side, so I'm going to put 16 squared over there. Then I'm going to put 2 radical 38. And don't forget to put parentheses around that to square it, because both the 2 and the radical 38 will be squared. And then the 10 is also being squared as one of the legs. 16 squared is 256. And how do we deal with this here? Yes, this square will cancel out this radical, so I'm left with the 38, but how does the square interact with the 2? Well, I'll just do this on the side so you can see. Essentially what you're doing, it feels like the distributive property, but there's no plus. The square gets sent to there and to there, so each factor gets the square. So now I have a 2 squared and a radical 38 squared. So what happens here? I get a 4 here, and the square kills the radical times 38. So 4 times 38 is what I'm going to write down there. 152 plus 100. Now, I should put a question mark here the whole time because I'm unsure of that. 256 comes down, question mark there, and 252 comes down. Now I can make a conclusion. They are not equal, so my answer is not a right triangle. So here we are. There are two other aspects to the Pythagorean Theorem Converse. Not only can we tell that the triangle is a right triangle, but if it's not a right triangle, we have other ways, or we have other classifications we can do. So let's take a gander at this first one. If we discover that c squared is greater, c squared is greater. So logically thinking, c squared is greater. So if this is my original situation right here, and let's pretend that's A, B, and C, what would happen if I extend C out? So if I extended C out and I kept AB the same, notice what would happen. What happens to this angle right there? If you push those out, the angle gets bigger. So, in conclusion, if I push C greater, then the triangle has to be obtuse. And of course, obtuse means greater than 90 degrees and less than 180. So, by extension, what if c squared was less than? We can conclude we have an acute triangle. Again, what's the logic behind that? If I shrink c down here, then I now get a smaller situation, and these two shrink down, and we see here that this angle is smaller now. So it's an acute situation. So let's try some examples. Number one, if I had a triangle and not drawn to scale, and this was a 4 here, this was a 4 here, and this is a 6 here. So what would we have? Well, clearly this is my longest side there. So let's start off with c squared is equal to, with a question mark, I don't know. If you want to leave that part blank, like c squared blank, a little box, or c squared line under, because I don't know what's to fill it, or just leave it blank entirely, that's totally fine. How you use it is up to you. I'm going to use the question mark, and then in the end, make my assessment. So now I put my legs here, what seem like my legs, 4 squared plus 4 squared. And I forgot to make this into a 6. All right, so I bring down a 36. I don't know if it's equal to, and I bring down a 16 plus a 16. So here I get 36 is greater than 32. So because the c squared is greater, my answer is obtuse triangle. Now, how do I even know this is a triangle? I forgot to do that double check. Well, notice here that 4 plus 4 is 8. It's bigger than 6. So therefore, we know it is a triangle. It can form a triangle. How about over here? Six, 8, and 9. Clearly 9 is my largest, so I am going to 9 squared. I don't know if it's equal to 8 squared plus 6 squared. Bring down the 81. I don't know. 64 plus 36. 81. And over on this side is 100. So I clearly see that my c squared is less. So my answer here, if I had to classify, would be acute. Oh, such an acute triangle. The next thing we want to check is figuring out what type of triangle we do indeed have. So first off, we're going to decide if the set of numbers can represent the side lengths of a triangle. So can this form a triangle? And if so, what type of triangle is it? So there are two aspects to our problem. So the first thing to do is add the two smaller sides, which here I get 68, and clearly that's bigger than 48. The only thing this tells me is that yes, it is a triangle. Yes, it's a triangle. Second, now that I know it's a triangle, I have to use the Pythagorean Theorem Converse. This here is my longest side, so I'm going to call that my C. I don't know if it's equal yet, and my two potential legs are 28 and 40. Now when I multiply out, I get 2304. I don't know if they're equal. 784 plus 1600. Bring down the 2304. I'm going to leave the equal blank right now. And this equals 2384. So it's actually not equal. Clearly we see that the blue side is greater. So because my C squared is less, my answer is yes, it's a triangle, and it's an acute triangle. Notice I did not make my answer about acute. I did not use this up here. I used this to determine if it was a triangle. I used the Pythagorean Theorem Converse with the squares to figure out what type of triangle. Now let's look at B, some decimalization. So is this a triangle? Well, add these two things together, these two potential side lengths, to get 17.9, and since those together are greater than 13.9, I say yes, it is a triangle. Now I need to use the Pythagorean Theorem Converse to determine what type of triangle it is. So I just have to substitute in. C is here, so 13.9 squared is equal to, question mark, the other two, 5.7 squared plus 12.2 squared. Over here, I get 193.21 equals, with a question mark, 32.49 plus 148.84. My final step here, 193.21, I'll leave a blank, 181.33. So clearly the red side is greater, C squared is greater. So in this case, I have an obtuse triangle. So, just to refresh, first I use the sum of the sides to check to see if those two are larger than the third side. That determines the triangle. Then I use the Pythagorean Theorem Converse to determine what type of triangle. Two different equations to determine triangle and then classification.